we struggled a little bit with the assignment, so we're just going to look at the problem setting. So if you got it right, maybe you can help explain it. If you got it wrong, hopefully we can get it corrected. Okay, what you're given in problem set or lesson set B, problem set 1, says find the area of the shaded region. The area of the shaded region is the area of the square minus the area of the circle. So your shaded region is going to be given to us as these corners of your square. And the radius of your circle is what? 4. So they tell us it's going to be the area of the square minus the area of the circle. They tell you that. So if I set it up as far as formulas, the area of the square, how do you find the area of the square? Length times width. So I got to find that distance right there. That is the same as the diameter of the circle, and the diameter of the circle is 8. So it's a square, it's 8 by 8. So you have to take 8 times 8, which is 64. What's the formula for area of a circle? Pi r squared. What is the radius squared? 16. 4 squared is 16. So you end up with 64 minus 16 pi. Some of us didn't have the 16 pi. Some of us had a problem with the 64. What are the units? Square meters. So I think I would rework that somewhere if you happen to have missed that problem. Is there a question on where any of those values come from? We're good? All right, number 2. If you look at number 2, or not lesson 2. If you look at number 2, the figure itself, I can tell you this much right now too. Is it the seniors or the juniors? The seniors. The seniors had this problem. This is not going to let me do this. There we go. And then I'm going to go to. All right, I'll create it myself. No. I shouldn't have to. Did that. So it looks something like this. Now the seniors have this problem that they were working on in their assignment set, and it doesn't give them everything off to the side that yours does to tell you how to find the area of that shaded region. The first thing that's really going to help you with these types of problems, I know it seems like a little bit of work, but write down the formulas and then substitute in the information and solve. Some of you just aren't simplifying your problem enough. You're close to your answer, but you need to finish simplifying it. So they tell you the first distance there is 6. Then you have a 4, you have 3, you have 9, and they want to know what is the area of the shaded region. So if you read what's above, the area of the shaded region of the figure can be found by subtracting the areas of the rectangle and 2 small triangles from the area of the big triangle. So what we need the area of the large triangle, which is going to be found in green right here. That large triangle. And you're going to subtract from it the area of a rectangle, which is right here. And we're also going to subtract from it the area of a triangle. Let's just say this triangle right here. And then you're going to subtract from it the area of another triangle, which is found right here. That's what you're going to do. You have two formulas you need to know. What's the formula for area of a triangle? Triangle is base times height divided by 2, and a rectangle is just base times height. So what is the base of your large green triangle? No, it's a sum. The base of it is 9 plus 3, which is 12, and the height is 10. Then you divide by 2. 120 divided by 2, which is 60. Now I want the rectangle. That's 4 times 3, which is 12. Do not divide by 2 because it's a rectangle, not a triangle, which some of you divided by 2. Yes. Then you have the purple triangle, which has a base of 9, a height of 4, and you have to divide by 2. 2 goes into 4 2 times. 9 times 2 is 18. Then you have the blue triangle. And the blue triangle, the base is 3, the height is 6, and you divide by 2. So you get 9. So it's going to be 60 minus what? What happens if you group those negatives right there together? 39. What's 60 minus 39? 21. Now don't forget, we got to put units down because some of us are struggling with units. So your units would be square meters. Number 3. I think some of you struggle with number 3. Hey, press back or shut the fan off. Was it okay to change the slide? Or does somebody need it back? We're good? Got the, no? Good. So this particular problem, what they do is they ask you to find the area of the shaded region again, but I believe they tell you a little bit on how to find it. Maybe not. Maybe they don't on this one. Was that good? Good therapy there? Yeah. Okay. I was going to say we could have sent somebody else, but if you're supposed to be stretching it and walking throughout the day, then how are you doing that? All right, so looking at this figure, what they tell you, here's where some of you messed up. This is 8. You have 8 and 8. So the radius of your circle is 8. They want you, it says the base of the triangle is a diameter of the circle. That part is the part most of us messed up on. The altitude of the triangle is the radius of the circle. Find the area of the shaded region. If you were to tell me, I'm guessing you would say it's the area of the circle minus the area of a triangle. Would you agree with that? The area of the circle is going to be pi times your radius squared, pi r squared. You subtract the area of the triangle. What is the base of the triangle? This is where you messed up. What is that base? 16. Some of you put 8. The base is 16, the height is 8, and you divide by 2. 2 goes into 16 8 times. What's 8 squared? 64. So you have 64 pi minus 8 times 8, which is 64. You don't just come out with pi, because you would have to multiply 64 times 3 first and then subtract 64 from it. So this is what you cannot do. You can't group those together. Pi terms are separate than whole numbers or integers. Centimeters squared. Question. Is this where some of you messed up? Don't flip it. Some of you had it flipped because you're used to putting a whole number first and your pi second. But in this case, you got to have the circle minus that. And don't leave it as just pi. What's 64 times 3? 192? So it's like 192 minus 64, which is not just 3.14. So you can't just subtract those two from each other. Are we good with that one? May I move on? Number 4. Number 4 gives you a figure that looks like this. Actually, I should probably put these up on the Elmo. I'd have it better. Sure, when I want it to go to the other, it doesn't. When I want to shorten it, it won't. There's your figure. Something like that, and they tell you that this has a value of 2. And they give you 3 and 2. What are you supposed to find? Perimeter, which is the distance around, correct? So we're going to look at straight pieces. How much is this one? 2. And this one right here is 2. And this is 3. So right now, how much do you have? 7. I still need this piece right here. How long is that piece? 7. Because what's the distance right here? 2. And the distance right there is 2, because it's the diameter of the circle, which is 4, plus the distance here, which is 3. So this length across the bottom is 7. So I add that piece. What do I have left in the perimeter? That curved piece right there. Circumference of a circle. What's formula for circumference of a circle? 2 pi r. How much of it do you have? Half, which is just going to make it 2 pi. Some of you had 4 pi there, I think. So 7 plus 7 is 14, plus the curved piece, which has a length of 6.28 or 2 pi. Your units would be what? Meters. It's a length. Are we okay with that? Move on. Stuart Jameson, got it? Okay. Number 5. Number 5 gives you a circle and asks you to find the area of a sector. And in that sector, it's a certain degree measure, which is, I believe, 40 degrees. The radius is 5. Find the area of the 40-degree sector of the circle. Dimensions are in meters. Area of a sector. Remember, what they are asking you to find, they are asking you to find this shaded piece right here. They didn't shade it for you, but that's what your sector is. So to find that, that's equal to area of the circle, or pi r squared, times your angle over 360. Some of you just did not finish this one. The area of your circle, the radius is 5. 5 squared is 25. So that's the same thing as 25 pi. Your angle measure is 40 over 360. So let's reduce. How do you reduce that? Divide by 10. Is that okay if I do that? 4 goes into 36 9 times. So some of you left it as this. You have 25 pi times 1/9. Go ahead and multiply those together. What do you get when you multiply those together? This is like 25 over 1. You multiply the numerators together, and you multiply the denominators together, and write it as 25 pi over 9. Units would be square meters. Some of you are leaving it in this format right here. An approximation. Can you tell me an approximate value of that right there? What's 3? The overall answer? Yeah, not quite. Pi approximation is 3. So it looks something like this. If I want to approximate, it's like 25 times 3 over 9. 3 goes into 9 3 times. What's 25 divided by 3? 8 something, right? So it's going to be a little over 8, somewhere around there for an answer. You see how you can approximate that? Turn your pi to a 3. Number 6. All right. Now they're testing your you're going to have to get some visual concepts here. Because if you look at it, they're making it a pyramid now that's 10 centimeters high. The base of the pyramid is the triangle shown. So there's your triangle, the base of a pyramid. What does that mean if it's a pyramid? Comes to a point. So all 3 of those sides are going to extend out here like this, right? This is what they are giving you, and I think I put it away. It's not this base, but that's what that right triangle is representing, is the base. And what your cone is doing is it's coming out towards you like this. So it comes to a point. They ask you to find the volume of that cone. How do you find the volume of a cone? Area of the base times the height, divide by 3. Or some of you may say it's 1/3 area of the base times the height. Same thing. Okay? That's the same thing. So we look at it. We got to figure out the area of the base. What is the area of this base? 4 times 6 divided by 2, which is 12. So the area of the base is 12. I take that times the height. What is the height of the pyramid? 10. And some of you stopped there and said your answer was 120 cubic centimeters. That's if it's a prism, if it has this triangle here and another triangle out here, and it looks more like this figure. You found this. But it comes to a point, which means if it comes to a point, what do you know? What do you have to do to it? Divide by 3. It's 1/3 of it. So I need to take this and divide by 3, and what should your answer be? That's correct, 40 cubic centimeters, not 120. Yeah, some of you, your area, or your units you need to look at. So number 7. Only had 10. Bear with me, we're about done here. Ripped a hole in what? Okay, not drawn the best, but we get the right idea. 3, they tell you the radius is 2, so this is 3. The 2 parts, you have 2 answers. The first one, it says find the area of the figure. Right there you got a figure. What's the area of that? The area of that is 2 shapes, right? So the area of the figure. The area of the figure is the area of a rectangle plus half the area of the circle. Area of your rectangle, what's the length of your rectangle? Yeah, this distance right here is the diameter of your circle. They tell you that radius is 2. I don't know why I put the 2 out there. Sorry. Okay, so the radius is 2, so the length here is 4. So the area of the rectangle is 12. Then I need the area of the semicircle. So it's going to be pi r squared divided by 2. So you have 12 plus 2 squared is 4. So you have 4 pi divided by 2, which is just going to make it 2 pi. So the first question is, what is the area of the figure? That's the first question that they ask you to find. And that's going to be 12 plus 2 pi. Your units are, what's it measured in? Square meters. There's the first question. Now, if you missed that one, I'm pretty sure you were going to miss the next part. The next part was find the volume of the cylinder 8 meters high that has this figure as its base. So how do we find the volume? It's a cylinder. That's 4/3 pi r cubed is the volume of a what? Sphere. That's the volume of the sphere. What about for a cylinder? Nope. That's surface area of a sphere. Cylinder. Area of the base times the height. That's all it is. Just area of the base times the height. Do I know what the area of the base is? Yes. We found it. It's right there. So the area of the base is 12 plus 2 pi. What is the height of it? 8. I think. Now you're going to make me look again. It is 8. So now you use the distributive property. What's 12 times 8? 96. So the volume of your cylinder is 96, and 8 times 2 pi? 16 pi. Volume, your units should be cubed. There's the second answer to that problem. Is there a question over that? Bryce, number 8, you were giving me formulas for. May I change the slide? Number 8. Number 8 doesn't give you a picture, it's just words. Find the volume and surface area of a sphere with a radius of 6. There's where the 6 came in. So the volume of a sphere, how do you find the volume of a sphere, Bryce? Four-thirds pi r cubed. And the volume is going to be equal to, or volume. And your surface area of your sphere is 4 pi r squared. Units for area are squared, so your radius will be squared. Units for volume are cubed, so your radius will be cubed. So now we need to calculate. It's going to be 4/3 pi. The radius is 6, and I'm going to cube it. I'm just going to write it out 3 times and saying, instead of saying 6 times 6 is 36, and then take that times 6 and get 216. Instead of doing that, I'm going to make some calculations simpler, and I'm going to start to reduce. 3 goes into 6 2 times. What's 6 times 6? 36. 4 times 2? 8. So I'm going to take 36 times 8. 6 times 8 is 48. 8 times 3 is 24, plus 4 is 28. So you get 288. Somebody forgot the pi. Is it meters? Centimeters. So it should be cubic centimeters because you were talking about volume. Eight, the first part. There's two parts. It says find the volume and the surface area of the sphere. Question on the volume of the sphere. Now we need to find surface area. Surface area of a sphere is 4 pi, and your radius is 6. So I got to square that. So you're going to take 36 times 4, and you end up with 144 pi square centimeters. So for number 9, they say find the area of a 72-degree sector of a circle whose radius is 10. So this is 72 degrees, the radius is 10. Here's the shaded region, or the sector that they're talking about. Once again, how do you find the area of a sector? Pi r squared times the angle over, central angle over 360. So it's going to be pi, what's your radius? 10 squared, times the angle, which is 72 over 360. What is 10 squared? 100. So you have 100 pi. Now, does 72 go into 360? Yes. If you were to take 72 times 5, you get 10, 35, 36. So this reduces down to 1/5. So some of you, we need to finish. Or you said 100 pi times 1/5. What's 1/5 times 100? Or what's 100 divided by 5? 20. So your answer needs to be written as 20 pi, and your units are centimeters. Do you see how you perform those calculations? Since some of you said it's the calculations that you were struggling with. Oh, units squared. Thank you. Units should be squared. Okay, we had one left on your assignment, which was problem number 10. Problem number 10, you had to find what? Somebody found area part of this. What did you need to find? You needed to find the perimeter. Okay, I don't know how well I'm drawing it. Probably not very well as far as to some size, but this curves out here like this. This curves in here like this. Okay. And they give you some values. They say that this radius right here is 2. They give you the height right here as being 2. And they tell you this base right here is 8. All right, here's what we got to find. Perimeter, the distance around the object. If I look at these two pieces, I don't have to find them separately. What's the combination of those two pieces going to equal? 8. So I know I have 8 there and 8 here, which is a total of 16. So far you have 16. Some of you had that in your answer and you forgot these two other straight segments right there. What's the sum of those two segments? 4. So far your answer is going to have a value of 20. Those are your straight pieces. Some of you, I think, forgot the 4 or the 2 2s. Now, what do you notice about, if I were to draw this, I have this and this. If I put those together, what have I created with those two segments? A full circle. I've created a full circle, and what is the formula for perimeter or circumference of a circle, 2 pi r. So what is the radius? 2. So you have 2 times pi times 2, which is 4 pi. Now, if you wanted to, you could say to find this curved segment that curves in, that's going to be 2 pi r, and it's half of it, which this curved piece is 2 pi, and this curved piece is 2 pi, but 2 pi plus 2 pi is 4 pi. The same thing as if we just found the circumference of one whole circle. We can do that because the radius is the same for both of them. So therefore, we get 20 plus 4 pi. And your units would be yards, because we're just talking about perimeter, distance around.